Evaluate the tangent of the inverse sine of negative root 2 over 2 and cosine inverse of tangent 11 pi over 6. So let's evaluate this step by step. So first we got to get the inverse sine of negative root 2 over 2. So we draw our triangle, and this is going to be the range of inverse sine. Again, is in quadrants 1 and 4, between negative pi over 2 and pi over 2. And since we have a negative sign that we're looking for, we're going to draw it in quadrant 4. So the y, or the opposite, is going to be negative root 2, hypotenuse 2, adjacent square root of 2. And our angle is going to be negative pi over 4. Let's just call it theta for now. The reason why is because we're just going to be taking the tangent of this thing after all. And the tangent of theta is negative root 2 over 2. Negative root 2 over root 2, which is just negative 1. So the answer for A is negative 1. So upon drawing the angle that we need, which we knew was negative pi over 4, we're taking the tangent of it, and so we just called it theta, took the tangent of that theta, and negative root 2 over root 2 is negative 1. For B, we're going to go and find the tangent of 11 pi over 6, and then evaluate the inverse cosine of it. And remember, whenever we have the inverse on the outside, that's a restricted range, so we'll have to be careful with that. Tangent of 11 pi over 6, so that's going to be in the fourth quadrant. Pi over 6 is our reference angle, so that's going to be the negative 1, 2, square root of 3 triangle that you all have memorized. And so the tangent is going to be negative 1 over square root 3. So we're going to have the inverse cosine of negative 1 divided by the square root of 3. So in order to evaluate that, again, the inverse cosine has a restricted range of 0 to pi. We'll have to do is draw our triangle in either the first or second quadrant. Since it's negative, it's going to be in the second quadrant. And cosine is negative 1, and that's our x. The hypotenuse is square root of 3. And so this one right here, we well, is not one of our special triangles. We could use the Pythagorean theorem to actually find out the opposite side right here, but if this was a negative 1 and a square root of 3 and then a 2, we could sort of do it, but we don't have that here. So what we're going to have to do then is just approximate with our calculator. And again, it should be a value that's going to be in the second quadrant here. So go into our calculator, which I get as 2.19 radians.